My name is Matt Johnson, and I am a third grade teacher at Bowling Springs Elementary. And today I want to give you a little bit of information about our school science fair that's coming up very soon, as well as give you some tips for making a successful science fair project. So let's get started. First, a few dates to keep in mind, or a few facts to keep in mind about a science fair project is that for third graders at our school, these projects are expected this year. First and second graders are optional. They have the option of doing one for practice because in third grade, when they get to third grade, they will be expected to do one. In kindergarten, which is 4K and 5K, they're going to create a classroom project just to kind of get an idea of what it means to do a science fair project board. A few dates to keep in mind. Starting right now, as you're watching this video, students can begin working on a project at home. And so they have about a month, a little less than a month, to work on a science fair project. And these are due on February 8th, which is a Monday, at 8 a.m. And then throughout the day, judges will be coming from outside the school to come in to judge the science fair project and all the boards that have been turned in. So let's think about that for a minute. What do you think, as we're starting the science fair project process, what do you think is the most important reason to do a science fair project? Many of you may think that it's to win, and I get that. A lot of people that want to do a project, they want to do their best in hopes to get a reward. But thinking about how many projects are going to be turned in, there's going to be about 200 plus projects turned in. There's going to be a total of 18 prizes awarded for a science fair project, and so there's not really a good chance for, of course, we can't give every student an award, but let's think about what is the main thing, and let's keep the main thing the main thing. The purpose of a science fair project, or what should be the purpose, is to learn and to have an amazing learning experience that extends outside the classroom into our homes, and also involves family members to help take part in a child's learning that they're learning at school. And so I want to give you a few tips on what would make a successful project, not necessarily a winning project, but a successful project. And how are we going to define success? Well, does the child learn? Do they learn something new that maybe they didn't learn as in depth at school that they can possibly learn at home with family members? There's a lot of websites out there, and these are three that I found that are helpful to me when giving assistance to parents and to students for looking for topics, as well as even some of these websites actually have step by step what to do to learn a new topic or learn a new concept that they have been looking at school. So try out one of these, try out all three of them, try to find a good topic to do a science fair project. There are 6 categories in the science fair, and I'm not going to go in depth with these. You can feel free to pause the video and read over these and search each one of these. But there are 6 topics or 6 science fair categories, and in each category, with the science fair judges that are coming in, there will be 3 prizes awarded for each category, so giving you a total of 18 awards for each one. I do want to kind of push some students towards a particular category, and that category is right down here. The mathematics and computer science. We really want to look at how math and science work together. And so we don't really have many math categories, computer science. So if you really like math, try to find something that's related to math and choose that category that'll go along with your science fair project. So what are these judges looking for? Well, there's also 6 aspects totaling up to 100 points that science fair judges are looking for. So they have this little rubric that they're looking at. They're looking exactly what you see right here. This is the first half of it, scientific thought. Are they looking at students following the scientific method, which we'll look at in a minute? Creative ability and thoroughness. The next 3 aspects of it are they're looking at clarity, dramatic value, and technical skills. So if you want to read these a little bit further, you can feel free to stop and pause the video to go back and look at each one of these. But I do want to pause at the scientific method, because this is what is worth 30 points. And the judges that are coming in, this is what when they talk with me, since I'm not a judge, they talk with me and they say, you know what, I like this project because it has good science. I like this project because it had good science. And what they mean is that it follows this method right here. And there's 7 steps, and you'll see a lot of different variations of the scientific method, but I'll try to give you the most common one that you'll see. And there's 7 steps. Step 1, the question or a purpose. This is what you're trying to find out. Step 2, related information, which is like your research, a hypothesis, the materials that you use, the procedures, results, and what happened, and then a conclusion. I do want to stop a little bit at that first one, which is your purpose or your question. In third grade, we're teaching students what a question is and how to write a question. And it's not a question that you can simply look up. It's not a question that you can look up on the internet, like how far is it to the moon. That's a question that's easily Googled, if you don't mind me saying that. They want a question that is testable. And what is a testable question? Well, that's exactly what it is. It's a question that can be tested. And so I gave you an example of one, and I underlined 2 parts of this question to show you how this is a testable question. The question asked, does changing the height of the ramp affect the speed of a car going down the ramp? So there's 2 parts to this. Let's look at this first part right here. The height of the ramp. The height of the ramp is something that you, as the scientist, change. You can change it to be a low ramp, or you can change it to be a steep ramp. And so as you see in the picture, there's a low ramp right here, and then there's a higher ramp right here. That's something that you change. The second part is something that can be measured, the speed of a car. You can also, your project might be something that you measure the height of something. You might measure by counting something. And so this one is something that the student changes, and this is something that the student may measure. Let's look at an example one. An example one is, how does the height of buildings affect the damage an earthquake has on the city? Legos are real popular. Both girls and boys love Legos. And so thinking about this question, what do you think is the part of the question that you would change, and which is the part that you would measure? So as you're looking at it, hopefully you said that the height of the buildings is something that you can change. And as you see in the picture, there's small buildings, there's tall buildings. What do you measure? The damage an earthquake has on the city. So you may count the number of buildings that fall down. And so that is when you're writing a testable question, that's basically the foundation of your science fair project. That's what gets you going in the right direction. And if you have a good testable question, that's going to hopefully make a successful science fair project. And then, of course, this is what you want to find out. That's the question that you're testing, is what you want to find out. The second step is related information in your research. And so when you have your question, you want to find, all right, what do I need to look up? What do I need to research? Is there something that I need to learn a little bit about? And this is where students are really going to learn a lot of things that really might not even be necessary for their project, but it's something that they can take with them and that they can really use later on. And so they can also add in what they already knew about, the particular thing. If they knew something, if it was a Lego project, if they already knew something about Legos, if they already knew something about earthquakes, whatever it is that they're researching, they want to use this information to help them with their next step, which is their hypothesis. Based on what they know, based on what they learned, what do they think will happen when they test their question or when they conduct their experiment? And so before they conduct their experiment, of course, you can't conduct an experiment without materials. And so you make a list of all the things that you need. Or as you're doing your experiment, if you realize, I need to go get something else, you just add it to your list, and that'll be your materials list. The next part is your procedures. And this is a step-by-step, word-specific, what are you doing in your assignment? And this is where these judges, if you really want to make a good science fair project, if you really want to be successful, is to be very specific. Tell exactly what you do, so that if someone were to come behind you, they could visualize all these steps taking place. After that, after you conduct your experiment, and you want to, if I go back here real quick, in your procedures, sometimes you might want to do several tests, and a lot of judges who come up to me and say, hey, Mr. Johnson, this one was good because they did more than one test. They did several tests on this to make sure they get accurate results. And so once they got their results, you tell what happened. You write down your information, you put it into a graph, and I'll show you where you would put graphs on the science fair board in just a little bit. But this is where you take that information, your measurements, things that you count, and you write down your results. And the last step is your conclusion. And a lot of you may have done science fair projects when you were young, and a lot of science fair projects included a presentation. Now, we won't have a presentation. Students won't be standing at their boards explaining what they did. But this is where students are able to write out and tell what they did. Was their hypothesis correct? What happened, what they would have done differently, and there's an example here for you to pause the video and read if you want to. And in this conclusion, it's okay to say your hypothesis was wrong. One of the things I tell my students is that Thomas Edison found 10,000 ways. He failed 10,000 times trying to create the light bulb. And his response was, I didn't fail 10,000 times. I found 10,000 ways not to make a light bulb. In other words, he had 10,000 hypotheses proved wrong. He wasn't right. It's okay to have a hypothesis be wrong. And so it's okay. And if you were wrong, say that you were wrong. Tell why your hypothesis was incorrect. What could you have done differently? And that's the part that these judges are also looking at. Were you honest in here? Should you have done something differently? Did you forget something? Because, we're elementary students doing these projects. They're beginning scientists. It's okay to make mistakes. So make sure you put that in your conclusion. When presenting your project, of course, you can put it onto a project display board. The ideal boards are the trifold boards. I'll show you what the layout will in just a minute. But these are where you're presenting your project. It's okay if you don't put it on a trifold board. However, if your project is chosen to go on to regionals, that will need to be put on a project board, and we can help you if that's the case. Of course, you want to have your display board. You want to have some other materials that will go on your board, and other materials that will help you to put your information that I've just discussed onto your board. Here's an example layout of a board. This first part, of course, right here in the middle will be your title, and you want to have a catchy title. Don't want to just be Lego buildings. You want to have a very interesting title, very, dramatic if you were looking at the rubric on how it's displayed, creative. And then you go through the steps. Here's your first step, which was your question, your testable question, your hypothesis, what do you think is going to happen, your materials, step by step, what did you do, here's your results and what happened in your project. This is the discussion or your conclusion. These kind of can go together, actually, discussion of results and the conclusion. And then down here at the bottom right is your references and acknowledgments. Tell who's helped you on the project. If your uncle, who's a physicist, which how lucky are you that you have someone that can help you, or whoever helps you with your experiment, if they help you with, if you're launching things, if someone's going to catch you, put their name on there. Websites that you use, if you use Science Buddies, if you use Steve Spangler Science, whatever websites you use, put that on there. Science textbooks, your teacher, put me on there since I'm kind of helping you. That would be nice. Don't have to, but you can. And this is what you want to put on your board. And anytime if you want to put pictures of yourself putting on here, I'm going to get to some rules on pictures in a minute. But put pictures come over here in the space. Do like little space fillers that you can put pictures over there of you doing the assignment. So that's kind of like proof that you did it. And here's some things to think about when you are doing your science fair project. When you want to put your information, of course, I've just showed you where to put it on the board. But you also, this part that I underlined right here, do not use people's faces in your photos. That is a safety issue. It's also a fair issue because a lot of our judges live in the community. They may recognize some of our students' faces. And we want to make sure that the projects that they're seeing, number one, they don't have their names on the front. And number two, there are no faces or recognizable faces on there so that if they do see a face on there, they'll say, "Oop." We just want to make sure we're fair in that area. Other reminders: be creative, be neat. Use a computer to type your information if you put it on the board. Neat handwriting if you don't have a computer. And I will say, one of the coolest things seeing is not typed and printed words, but neat handwritten projects. I think, it's my opinion, are the coolest science fair projects. Again, don't put your name on the front of the board. Again, that's just to be fair and to be safe. Resources, of course, the internet. You're watching this video via the internet. Public library, our school library. Librarian can help you with anything regarding the science fair. And so one of the things that, when you're doing your science fair project, one of the things that, I encourage you to do is have fun with it. If you get to a point where you're tired and you're frustrated, step away and go do something else. Come back to it later. You have, plenty of time. Get started early, of course. Do a little bit at a time. Go through your steps. Take a day, do a step. Take another day, do another step. And just take your time on it. Make this a fun learning experience. Make this a family experience, a family learning time for you and your family. Again, this is a project that we want students primarily doing most of the work. We understand that students need parents to help with the projects. Also, there are students we understand that don't have parents to help them. In third grade, since this is a required project, third grade students will be able to take the class project and present it as their own. But we do want to highly encourage students creating their own project. But students that can't do it at home, they will have the opportunity to take the class project and present it on that day. Also, this is a student project. I know parents, you want to help your child, but please make sure that these are projects that are being submitted by the student. We don't need a bunch of parent science fair projects. This is for the students. So if you were there working on a project and your child's not there, walk away. If your child gets up and walks away, you walk away. And so it's okay for the child to work on it by themselves, but we want them to be there the entire time working on the project. And let them have fun doing it. I'm wearing a lab coat. Okay, I know they may not have one, but maybe they have a coat that they want to use as a lab coat. Not that it's going to protect them from anything messy, but just to get into the mood. Give them some goggles, if they have some goggles, to kind of play the part. As a third grade class project that we're doing, our materials that we're using, we're doing conductors and how heat is conducted and which cup or which type of container is ice able to melt the quickest, or which one doesn't melt the quickest. And so this is what we're doing as a class project. This is what they will be turning in if they do not do one on their own. And so that is a project that we're doing. They're going through the steps, or we're going through the steps with them together. And so hopefully this will be something that the students are very familiar with because we're doing it here at school. And so by that final day, February 8th, that's a Monday morning, projects are due. Your child can bring them on the bus. Your child, and of course, you're welcome to walk them in with them, with the project on February 8th. That'll be taking place in the gym, so the projects can go directly to the classroom, and we will have individuals go in and picking up the projects. There will also be a form for you to fill out that will be attached to this video that you can go on and submit your information, your child's information, teacher's name, and in an effort to get a board if you would like a board. So pay attention to that. If you have any questions, feel free to contact me at the school. I'll be glad to help out any way possible. Good luck to you. Hopefully this is a fun learning experience for you and your child.